My name is James Ranson. I am an architect at Comcast. I do software architecture for our video products. And I have created a software application called Trickster that is an accelerator for Prometheus-based dashboards. So a little bit more about me, if this is going to work. The one thing we didn't test. There we go. So a little bit more about me. I enjoy mountaineering. I like to watch football. I played piano for 35 years and all kinds of good nerdy stuff like that. My favorite video game is Zelda. And with that, I'll introduce Sheila, who's going to also talk to us today about some of the community stuff at Comcast.
Yes, hi, I'm Shilla Saebi, and I am an open source program manager in the open source program office at Comcast. I've been in this role for about 2 years. Prior to this role, I was a cloud operations engineer working on the OpenStack team. And yeah, I like dogs. I also play piano. And this is my first KubeCon, Cloud Native Conference.
Mine as well, actually. So here we are.
All right, so a little bit about my team and how it even ties into Trickster and how it ties into James and other engineers at Comcast. So the Open Source Program Office opened doors in 2017, and we support over 7,000 developers internally. We also have over 141 project repos on github.com, and we're also a 4-person team. So I focus on program management with community, and we also have an open source program manager who focuses on compliance. We have a software engineer who does compliance tooling, who just recently joined us, as well as our leader. And many of you may be asking what Comcast is even doing with open source, when we started, how long we've been in the game. So this slide is going to detail that. I won't get into every single point on the slide, but I'll go through a few highlights. In 2006, we were very large consumers of open source. This predates me. I've been with the company for 8 years, and so I actually went around and asked different leaders and different folks from different organizations and departments what they could tell me about open source history. 2013 is one that sticks out. Our Open Source Advisory Council was formed. This is a group that consists of our legal team, software engineers, network architects, security architects, as well as the Open Source Program Office. This is the team that James actually had to go through to get his project approved, and other engineers have to go through. This team has evolved since then, and we're trying to make the process easier for our engineers to open source stuff. 2015 was a big one. We have a project called Traffic Control, which is now a top-level Apache project. Recently, in 2018, it became one. Traffic Control was open sourced at that time, and in 2016, that was when we donated it to the Apache Software Foundation. In 2018, which we'll fast forward to today, about a month ago, we had an open source summit in Philadelphia, which was open to folks outside of Comcast. It wasn't just an internal thing. We plan on having another one in 2019. Also, that's when Trickster was born. And then we also have a fellowship pilot where we encourage our engineers to work on open source projects for 20% of their time. And as you can see, we're really doubling down on open source. So like James mentioned just previously, Trickster was developed in 2018, in May, I believe. May, right?
Actually, January.
January. Well, I think that's when it went open source.
That was April 1st.
Okay, April 1st. So spring 2018 is when Trickster was open sourced, and it's written in Go. And James is going to be doing a deeper dive into that in a few. Community has been really, really, really important to Trickster, and it was baked into the entire process from the very beginning. And we encourage you also, if you want to open source something, to do the same. And I'll dive deeper into some of the community stuff later once James talks more about Trickster. But the basic concept is that your source code is open, but also you want to cultivate a good community by having nice, welcoming documentation and just really prioritizing it. A few facts and, metrics about Trickster. We have 233 commits. We actually just pulled up that number recently. It keeps going up. We have 15 releases. 2/3 of our contributors are outside of Comcast. We really value that. We want to bring diversity globally from different companies as well, different thoughts. So we're super excited that they're not just Comcast contributors. And then, you can see here the number of stars and forks, over 500 stars. Awesome. And with that, I will pass over the mic to James. He's going to dive deeper into Trickster for you.
I have a mic on me. Thanks, Sheila. So I'll back up one slide just to talk about this a little more. In the very first keynote on Tuesday morning, somebody said, "We love stars. I love stars, so please star my project if you like it. I'd really appreciate having more of those." But let's talk about what Trickster is. So let me get a show of hands. Who actually has used Trickster or is using Trickster in their systems? Awesome. Do we have any Trickster contributors in the house? Awesome. Who has no idea what Trickster is before today? Awesome. That's what I want to see because I love talking about it. So as Sheila mentioned, I created Trickster last year at Comcast, and I'll talk about the journey as to why I felt like I needed to make it. But what it is, in essence, is basically a reverse proxy cache. And I actually call it an accelerator because it does more than just caching. That sits between your dashboard application, and as you can see on this diagram, I have a Grafana icon, but it'll actually work for any dashboard that has a backend to Prometheus. So it sits between that dashboard and your Prometheus database to help accelerate queries that go between those two systems. So here's a common problem. If you ever worked in any kind of industry where you work with users at large in America, you're probably familiar with the shape of this chart. And I'll just show you real quick. It's up there, so I can't see it. Never mind. So you're probably familiar with the shape of this chart. If I can now go back to the right place. There we are. The left side really high is prime time at night. As people go to bed, the chart goes down, and then as the pattern goes up, that's as people are waking up and using the service more. So this is just a basic usage chart of some systems at Comcast. And so I was building this dashboard to show charts like this, to show failure rates and those kind of things across some of our platforms, and realized that I didn't like the speed of our dashboard performance. And I'm going to explain kind of like what I discovered under the hood as I started looking at things. So I started out with Grafana, and I noticed that every time that you actually refresh your dashboard page, the entire data set is reloaded all the way from end to end, when really all you need to collect for a refresh is that last little sliver that's in purple on the screen now, because that's the only thing on the page that changes between refreshes of your dashboard charts. So what I set out to do is find a way to make our dashboard applications only request those little slivers instead of the entire data set every time the dashboard refreshed. And so that's what Trickster does. And I'll go into kind of how that works out in a minute, but I'll go through a little more things here. So each time, not only do I refresh that dashboard, am I collecting the whole data set, but so is everybody else who's also looking at that dashboard. And so what I found is on a typical Grafana dashboard, each line on the screen typically takes about 300 data points. It's going to be 240 to 320 depending upon how Grafana decides to do the step values. So in essence, every time your dashboard refreshes, you're asking for 300 times more data than you actually need to put that little sliver back on the screen to refresh that dashboard. So we do that in a few ways with Trickster. The first thing we do is we have what's called a delta cache. So as you can see on the screen here in the blue, imagine that's data that's already in the Trickster cache. And those orange lines that are outlined on the left and highlight and solid on the right, those are data points that Trickster needs to complete a user request that doesn't have those data points. So what Trickster does when you make a request from your dashboard to Prometheus is it looks at your request and the timestamps that you're requesting data between, and it determines what it has in that data set and what it needs. And so it'll adjust the upstream queries to Prometheus to only grab the data points you need to fill the cache, reconstitute the data set to the user, and send that back to the user. And what that means is those queries can be accelerated from about maybe a second, half a second, to about 40 times faster than that. And we'll show that in the demo in just a minute. Your dashboards really do go about 40 times faster with Trickster in the middle. The second piece of that is what we call step boundary normalization. The reason this is important is because if you've ever used Grafana and you have other people using Grafana next to you, and you kind of sometimes see their charts look slightly different from yours, a couple little artifacts and squirrely things, That's just the way Grafana works in that it looks from the start time, or the newest time, and works backwards. And so if you are 13 seconds behind on refreshing your dashboard from somebody else, you're going to see slightly different results on your screen. It's really hard to cache when everybody's data points are slightly different. So what step boundary normalization does is it actually aligns all of the data points to very well-known step boundaries, like the top of the minute or the top of 4 minutes or 6 minutes, depending upon how big your graph is and those kind of things. And so as step boundary normalization happens, that allows everybody's data points, and not just your data points, to all share the same cache, because everything is normalized across the same boundaries. That introduces another problem, though. And that problem is, well, what if we are on a 5-minute step boundary and it's 101? You've got to, let's go with 104. What happens at 104 and you have 4 minutes of blank space between that last data point and the newest data point? So the third feature, called fast forward, will actually go out and get that newest data point at all times and insert it into the data set as it returns that back to the customer, so that in addition to just having all those nicely normalized lines on the boundaries, you have that last data point that's always the most recent data point. So not only are your graphs really, really fast, but they're still as up-to-date as possible. A couple of use cases for Trickster. The first one is what I call cardinality creep. How many people in here have ever experienced the situation where you don't control the label values in your Prometheus? You might have to get those from somebody else. Here's an example. Let's say you have a dashboard and you're looking at the health of your application by requests coming in from users based on something like their device type, their iPhone or their iOS version, and you have those labels of those kind of device types and device versions, and those can start to expand, and you have no control over when Apple decides they have a 10S, a 10S Plus, a 10R. You have no control over when Apple releases iOS 12.1, 12.11, 12.12, and so as those label values start to creep out of your control, that can make your dashboards go a little slower. So the great thing about Trickster is, since we're reducing that data set that we're requesting from Prometheus down to just a small amount, those queries are still really fast, even when you have a very deep amount of cardinality in your Prometheus labels. Secondly, any incidental heavy dashboard usage. A lot of you probably are aware that whenever you have outages, your dashboards become the most popular thing people are looking at, because they want to find out what the hell is wrong. And so when you have these major outages, like a Sev1, for example, is our nomenclature at Comcast, typically you then get your VPs, your directors, and all these people looking and loading your dashboards on top of your engineers, customizing the queries and running ad hoc things, trying to figure out what's going on, and that slows the system down dramatically. And so I always like to point out that your dashboards, sadly, are the least performant during their times of greatest need. Trickster really helps with that, because in those situations, just like in the case of cardinality creep, the performance is dramatically improved even when you have heavy usage, because the queries are 300 times smaller. And then lastly, any ongoing heavy dashboard usage you might have. For example, if your team offers dashboards as a service to your company and you have a heavy user base of many different dashboards, and that creates many different time series within your Prometheus database, the Trickster solution will also, in that case, accelerate dashboards. A quick example of that, many of you are probably familiar with, in the spring of this year, GitHub was acquired by Microsoft. And so it turned out quite a few people decided to defect from GitHub and go to GitLab. And GitLab systems, had to have a monitoring system for all their users to watch, started to fall over because of the heavy usage after that move. And so they put Trickster in the middle and resolved a lot of their issues with scaling their Prometheus infrastructure. So in those heavy dashboard usage situations, also a great fit. I think we have a live demo now. And we do. So here we go. And what we're going to do for this demo is I'm actually going to spin up a Trickster container. We're going to add it as a data source in Prometheus and show you the difference in real time. So here is a quick dashboard. We've intentionally obscured what this data is, since it's, oh, that is not good. Let's see if this will help. There we go. All right, so this is just a random generic dashboard of data at Comcast. We've obscured the data so you can't know what it is, just so you'll know that it's really slow. So if I press this reload button, what you'll see there is, let me give it one more reload up here. So you'll see those are still spinning right there. If I go into the browser, we can actually watch those timings. 3 seconds, 4 seconds, 4.79 on the slowest one there. So let's add our Trickster in the middle. So for this, I just have a quick run Trickster script. If I were to cat that for you, you'd see it's just a quick Docker run. That's all it is. So now, and then in here, so I don't typo and fat finger something, I have a little file that gives me my URL to copy paste. So let me cat that real quick. And then I typo the word cat. All right. So we'll bring this guy down. We'll go into our data sources, add a new one. And since Trickster is basically a Prometheus accelerator, we will just add it as Prometheus. I'll call it Trickster. We'll paste the URL in there, hit save. Hopefully everything looks good. Awesome. Nice slow dashboard still. And now you'll see I have a new data source called Trickster in here. When I click on that, you're going to see it's going to be a little slow the first time because it is a cache, so it does have to actually cache the data one time. So let's clear that. And that was the wrong button for clear. There it goes. And now if I hit that refresh, wow. We've gone from 4 seconds down to 655 milliseconds for the slowest one. If I were to click refresh on that again, you'd see just as fast, 700 that time, and that's over LTE right now. We had to hotspot into the phone because of the slow Wi-Fi here in the building. And you can see each one of these graphs looks identical. So if I were to flip it back over to the Prometheus instance, slow again, same charts. Flip back to Trickster, back to being fast again. And if you go to that last data point, you can see, sure enough, 11:57:28, which is the current time. So we're still in real time, but significantly faster. So that's our demo for that. You can try that same demo. We have the instructions right on the README in our GitHub. Something else about the GitHub I wanted to mention is we just this morning added the who's using Trickster onto our README. I'd encourage everybody to, if you're using it, to please go do a PR, add your name to the list, and we'll get you on the list there and on our big README file. Roadmap here going forward, we would like to do this same thing on InfluxDB, Elasticsearch, if you use Circonus, that as well. So what we want to do is update the interfacing model to support all those upstream types, as well as any new ones that might come later. It's really important to us because we want to contribute this project to CNCF at some point, but I definitely believe that supporting all of these upstream types is important before we make that contribution. Secondly, we want to incorporate distributed tracing support because a lot of people have asked for that. There's been a lot of talk in the community about which way to go. It looks like we now, in 2018, have started to get solutions that are fully interoperable between all the different options for tracing. So we want to get that incorporated. So if you have any experience with distributed trace, we'd encourage you to contribute that as well. And then lastly, high availability is something we want to look at for things like, let's say you have two different Prometheus servers in a high availability mode, so they're both scraping the same endpoints. Well, what happens if one goes down for a little bit, but then it comes back? Well, then that might become the active one, and you're going to have gaps in your chart. So anytime your Prometheus, even their high availability, go down, when one comes back, you stand the risk of having gaps in your charts. So what we'd like to have in Trickster is the ability to know about your high availability infrastructure and layout, and be able to query all the Prometheuses in that high availability cluster, and then merge those data sets to fill the gaps no matter which high availability instance of Prometheus the Trickster hits. Does that make sense, everybody? Okay, good. All right, so those are the roadmap items we want to put forth in 2019 so we can get to contributing this project to CNCF. I'm going to turn it back over to Sheila to finish us up here with some more community stuff.
All right, really fabulous, James. Really proud of the work that you're doing. So we're trying to continue cultivating this community and building it. So some of the things Trickster has done since the beginning, I would like to share with you all because it's been really helpful and it's been working. So it's really important to have a very friendly and welcoming onboarding process for your contributors. Make sure that your documentation is up to point. James put together a contributor guide. There's a README, license files, and just having the right attitude for your contributors is really, really important. Also provide clear and consistent support. Sometimes I wonder if James even sleeps or what's going on with him. I see requests getting merged, pull requests getting merged just in the middle of the night, 3 a.m., 5 a.m. I know you're in Denver, but still it's typically late. Anyway, so he's been doing a fabulous job of just providing that support, but also we quickly realized that one maintainer is not enough. So now we're proud to say that we have another maintainer who is outside of Comcast that's also on this project. So make sure that you're really supportive of your new contributors, welcoming, and you're clear. James came all the way from Denver. So I run the Prometheus meetup in Philadelphia. If anybody's on the East Coast or around, please follow our group on meetup.com. We'd love to have you. But we had our first Prometheus meetup back in the fall, and James came and he did a talk on Trickster. It was very well received. We've also done this talk at the Open Source Summit North America. We're going to do the same thing. We're going to continue doing it. And then also the Go meetup. So it doesn't have to necessarily be relevant to the project. It doesn't have to actually be the Prometheus meetup. It just, as long as it's relevant to your project, then you can find meetups to go speak at. Also, we have a Trickster.io Twitter account. Please feel free to follow us. Any releases that come out, we make sure to tweet out any kind of testimonials we have or news and updates. They also go out on our Twitter account. We also have a Comcast Labs blog where we blogged about it and made sure that that was aligned with the date that Trickster was released. If you're interested to learn more about other open source projects at Comcast, you can visit comcast.github.io. We featured Trickster and then a number of other projects at the top of our carousel that we really want you to look at, but also please contribute back to if you're interested. And then I sort of found this interesting, borrowed this slide from Matt Broberg. He put out a blog post about the return of investment on stickers. And I won't read all of this, but the key takeaway is that stickers offer between 5x and 76x greater return. And with that, I will say that we do have a bunch of stickers here for you all, if you're interested. We have them in the back, we have them here on the stage, and you can come ask us for one if you'd like. And thank you. We have some time for questions, I think?
Yeah, I think we have 15 minutes for questions, if there are any.
Yeah, we have about 10 minutes for questions if anybody has anything to ask.
So we've learned about a few other exciting add-ons for Prometheus in this conference, Cortex and Thanos as well. So it sounds like maybe there's some feature overlap with some of the caching and performance improvements, but then also some things that are totally different, like the durability and long-term storage that some of those other solutions provide. So I would be interested to know, is there operability that's already been tested with those? Because it would be a shame to have to sort of pick one use case, but not, be able to plug in all of these things, right?
Definitely. So we do have users who use Trickster in front of Thanos already. And you can actually take a look at our issues. We've actually worked through issues to make that interoperable already. So most of the situations where we have interoperabilities issues, people submit those issues with us and we fix them pretty quickly. So we do have all of those things working currently.
Looks like we have one more question in the back here.
Good, this will help me project. How long do the data points live in the cache?
That's a good question. So Trickster is highly configurable. One of the first things I did as I built the app was to build in a lot of configurability in terms of TTLs, not only on individual data points, but also on the entire cache of a particular query itself. And that's one of the great things about Trickster I didn't mention is it is adaptive to all of your queries. So if you're using things like recording rules, that's great. And I highly encourage those. There are situations where you might not control your own dashboard data sources, right? You might not control everything. You might just run the dashboard as a service. And in those cases, it's really important to be able to cache random queries that any user of your dashboard that creates those can cache. And so we do adapt those queries adaptively. Each one is stored in its own little hash entry, and each one of those hashes has a configurable TTL on it, as well as how far back in time the data points can last. And both of those are independently configurable. We do also offer a multi-origin solution with Trickster, so if you have one Trickster to many Prometheuses, you can customize that TTL by upstream origin as well.
Any other questions?
Awesome. Well,
You
we
can
have
find us-
lots of stickers. You want
Yeah.
to come up and grab a sticker, ask more questions. I'm going to be here until probably 12:30.
Yep.